All right. Prop 29 says a straight line falling on parallel straight lines makes the alternate angles equal to one another, the exterior angle equal to the interior and opposite angle, and the interior angles on the same side equal to two right angles. So the claim is that if you have two lines that are parallel, then you get these three sort of results. I don't know why that was so hard for me to find a word for that. So yeah, and this is kind of like the other direction of Prop 27 and 28. Because Prop 27 and 28, 27 was the one that took this first, the alternate angles are equal to one another, and said, all right, well, that makes the straight lines parallel. And then 28 was the one that said, well, if either of these are true, then again, the straight lines are parallel. So now we're going the other way, and we're saying, well, if the straight lines are parallel, then these three things hold. So kind of interesting in that regard. The other reason that it's really interesting is because this is the first time we got all the way to Prop 29 and we didn't have to use Postulate 5. Sorry. So this is going to be the first time that we use Postulate 5, which is crazy, right? Because that was an axiom, and we were able to prove 28 different truths about geometry without appealing to that axiom whatsoever, which is, again, one of the reasons that people kind of felt for a really long time that maybe Postulate 5 can be proved, because, there's so much that doesn't rely on Postulate 5 at all. We were able to get all this way, so they thought, well, maybe Postulate 5 can be proved, and then, of course, because Postulate 5 is just kind of a strange, clunky postulate, it doesn't feel like a postulate at all. It feels like it should be a proposition, but it's not. It's a postulate. All right, so let's jump into this. So, proof. We begin by letting AB be parallel to CD. So this is where it's different from the last two propositions. Proving the parallelism between the two lines was the conclusion of the last two propositions. Now we're taking it as the hypothesis. All right, so, and how shall we start by showing that the alternate angles are equal to one another? So in particular, what we want to show is that AGH is equal to GHD. So these two lines, or these two angles are equal. How are we going to prove that? Well, we're going to start by assuming that they're not. So assume, towards a contradiction, I guess I should write that just to be really clear. Sometimes for your readers, it's good to be very direct about when you're doing a contradiction, otherwise it's kind of confusing. So this is by contradiction. I should have written that down, but I didn't. But assume that AGH is not equal to GHD. Well, if they're not equal, then one of them is larger. So we'll assume that AGH is larger. All right, well, from this inequality, let's add angle BGH to both sides. So then angle AGH plus angle BGH must be greater than angle GHD plus angle, oops, that should be a B. It's not going to erase very well. That's all right. Angle B. Then comes the G. Angle BGH, right? So we're just adding BGH to both sides. That's all. The inequality holds as long as we add the same thing to both sides. Well, let's take a look in the diagram at what we just did. We just said that AGH plus BGH is greater than GHD plus BGH. So we'll notice that AGH plus BGH, well, those form two right angles by, what was it, Prop 13, since it's a straight line, basically. But angle AGH plus angle BGH equals two rights. which means then that angle GHD plus angle BGH is less than 2 rights. Let me try autofocusing this again. That looks a little bit better. So, angle GHD plus angle BGH is less than 2 rights. Because we're saying AGH plus BGH is 2 rights. Right. And here's where postulate 5 finally comes in, because postulate 5 is the one that says that if you have that situation where these internal angles are less than 2 right angles together, their sum is less than 2 right angles, then these two lines, AB and CD, meet on that side of the transversal. Let's see, I'm just reading what Euclid says, but he says, but straight lines produced indefinitely from angles less than 2 right angles meet. So I'll say then, by postulate 5, AB meets CD. And that is a contradiction, right? Because by hypothesis, they're parallel. So contradicting that AB is parallel to CD. So this assumption was incorrect. So angle AGH does indeed equal angle GHD. And that's the first part of what we wanted to prove. So what does he say? It says, therefore, the angle AGH is not unequal to GHD, so they're equal. And then the rest of this, we can prove the other two sort of conclusions here. We can prove directly, I believe. Yeah, it's not a contradiction. So that's the first part. Next part, by prop 15, alternate angles are equal. By prop 15, we have that angle AGH must be equal to EGB. Right, and we know that we just found that AGH is equal to GHD. So, angle EGB is equal to angle GHD. So EGB equals GHD, which is the second part. That's the exterior angle equal to the interior and opposite angle. And let's see, just as a note, in the Heath translation, this is, for whatever reason, this is justified with common notion 1. I don't know, like the last 5 or 6 propositions we've been able to make some of these conclusions without, citing common notion 1 or whatever, or postulate 1 or whatever it was. And then here he starts citing it again. I don't know, feels a little bit arbitrary to me. Maybe there is some good reason. All right, so there's that. And then we can get the last result pretty quickly. How do we do it? We add BGH to both sides. So, angle EGB plus angle, just make sure I do it right, BGH, yep, is equal to angle GHD, oops, plus angle BGH. Right, so again, let's look at the diagram. So we're saying that EGB plus BGH is equal to GHD plus BGH. So, but note that EGB plus BGH, well, that's a line set up on another line, and we have a proposition that says that that's equal to 2 right angles. So by, let's see, which one was it? Prop 13. Angle EGB plus angle BGH equals 2 rights. So it follows then angle GHD plus angle BGH equals 2 rights. And that was what we needed to prove, right? GHD plus BGH is 2 rights. Yeah, the interior angles on the same side are equal to 2 right angles. So, there we go. That's the proposition. QED, therefore, etc.